Hi there. Let's take a look at Unit 6, Lesson 2's reading guide. We've done a little bit of work with quadratics before, but this lesson is going to focus on the standard form. Remember, we've seen standard form before when we have been using maybe the quadratic formula. Notice that standard form does not have any parentheses being squared. Everything seems to be multiplied out. And so we will look for these techniques to use when we are in standard form. I think this is a big one that you definitely want to have for your notes. This is the formula to find the x-coordinate of the vertex. Now you may be saying to yourself, wow, that looks familiar. It does, okay? This is the first half of the quadratic formula. If you were going to have the whole quadratic formula, you would have this plus or minus and that big ugly square root we are so familiar with in the quadratic formula. So let's put this good formula to use. Look at number 9. We're being asked for what the vertex and the axis of symmetry is for this function. Now, because we're in standard form, you're going to want to first identify A, B, and C. So A is -2, B is -12, and C is 5. Notice how I took those. A is the number in front of x squared, B is the number in front of x, and C is the constant, the number by itself. So while we are asked for the vertex first, we're going to have to find the axis of symmetry first because it's the first half of the vertex. So we'll look at the axis of symmetry by finding -b over 2a. We'll substitute in -12 for b, but there's already a negative there. So we're going to have -12. You may be saying, that's silly. And it is, okay? We will simplify it here in a moment. Then I've got 2 times a, or 2 times -2. So this is x equals negative is a positive 12. And then 2 times -2 is -4. So I've got x equals -3. All right, now we've got the axis of symmetry, but we've also got the first half of the vertex. So we know now that the vertex is -3 and some y value. What we don't know is what that y value is. So once we know the axis of symmetry, we take our x value and we plug it back into the original function. So we're going to substitute -3 in for x. Notice that I'm putting -3 in parentheses. It makes me be aware, a little bit more aware of where the multiplication steps are. So I did that on purpose. Now remember, when you evaluate this, you've got to follow your order of operations. So you've got -3 squared, which is 9. Try not to skip too many steps in here so that you don't make any mistakes. Then, order of operations, we multiply, right? -2 times 9 is -18. 12 times -3 is -36. I do see that negative again, and plus 5. So I'm going to come back through and change that minus negative to plus positive. I've got now -18 plus 36 is 18. Plus 5 is 23. So now there's my second half of my vertex. So I know my vertex is at -3 and 23. Again, the first half of my vertex was my axis of symmetry. The second half I find by plugging into the original function to get that y value. Now that we know these pieces of information, we can use them to graph. Okay, so let's start by plotting our vertex. So I've got -3. Now notice my graph's going by 2's. Okay, so I know -3 is going to be somewhere in here and 23 going to be somewhere in there. Okay, I know that this graph turns down. Oh, you may be saying, how do you know that? I know that because that a value is negative. And anytime that a value is negative, I know this parabola is going to do something like that. Now, I like to find a few more points for this graph. I particularly will do a t-table where I find values on either side of the vertex. So I might find the value at -4. I for sure want to find the value at 0. I might even find the value at -1 because it's on the right side of the vertex. And I'm going to plug those in. You can use your calculator if you want to kind of see what these values look like. I'm going to do them quickly because you can type them in your calculator. -4 squared is 16 times -2 is -32 plus 48. -32 plus 48 is 16 plus 5 is 21. So I've got -4 and 21. Let's put in 0. 0 is pretty easy, right? And that gives us 5. There we go. And then, of course, we'll put in -1, just because it's close to the vertex. Right? So I'll do this one again. You can type this in your calculator. -1 squared is 1 times -2 is -2 plus 12, which is 10, plus 5 is 15. Okay, so we've got our parabola, looks something like this. Now remember, we're not drawing a perfect graph. If I were drawing a perfect graph, I would graph a whole lot more points, okay? But I've got a general idea. I definitely know where the vertex is, and we've done a good job of a sketch here. All right, look at 11. 11 is asking us for what is the vertex form of this? Well, this is not in vertex form. This is in standard form. So let's remind ourselves of what vertex form actually looks like. Vertex form is the one with the parentheses squared. So we have got to rewrite this so that it has that parentheses squared in it. We're going to have to use a process called completing the square, which just sounds difficult, doesn't it? We're going to try to make it as easy as possible for you. Follow along with me as we go step by step. Okay, oops, no squared there, just a y equals x squared minus 6x. I am placing some blanks strategically in this function in order to create space that I need to manipulate my expression to fit this parentheses squared. You will see where they fall out here in a little bit. The question then becomes, how do I know what to put in those blanks? And it all stems from this guy right here. So this guy tells us a lot, this -6. If we cut him in half, we get -3. If we square him, we get 9. And that is the value that goes here. And forgive me, this is not a plus. This should be a minus. And here. The reason it should not be a plus is because if I add something here and I turn around and subtract something of the same value, I've essentially done nothing to the expression. You may be saying, well, Dr. May, how does that help me? Well, I'm glad you asked. Let me show you. Now look at what we have. 3 minus 9 gives us -6. This is what we call a perfect trinomial because it factors into x minus 3 squared. Where'd the 3 come from? Well, remember this guy and how we cut him in half? That's where the -3 came from. So now we've rewritten this standard form into vertex form by a process called completing the square. All right, one more to go. Look at number 12 here. We're being given the equation for the height of a ball in feet above the ground after t seconds, and we want to know how much time will it reach, how much time will pass before it reaches a height of 20 feet? Always make a note of the ones that are on the test, right? And a height of 20 feet in for H. Now we have to solve. We have to solve this just like we would any quadratic. And so we're going to move this 20 to the other side by subtracting it. That gives me 0 equals negative 16t squared plus 32 minus 11. And that just doesn't even look nice, does it, at all? So we're going to have to be creative as we try to figure out, we're going to actually use the quadratic formula. So I want you to remember quadratic formula. We know that A is negative 16. We know that B is 32. And we know that C is negative 11. So let's plug those into our quadratic formula. Remember, the quadratic formula is not something you should memorize, but it is something you want to have in your notes so that you can come back to it again and again as you need it. So let's plug in these values. We've got negative b, so we've got negative 32. Then we've got b squared, so 32 squared, I don't know that one off the top of my head, so I'm whipping out my handy dandy calculator to do that heavy lifting, minus 4 times a times c, all over 2 times a. So 2 times negative 16 is negative 32. All right, let's do a little cleanup under that radical. So I've got negative 32 plus or minus. I've got 1024 minus, and then let's multiply 4 times 16 times 11. I do notice the signs. And then I've got divided by negative 32. All right, one more step to clean up all the way underneath that radical. So we'll do that subtraction. It looks like I've got 320. And this is where we're going to our calculator, right? I'm going to type in negative 32 plus the square root of 320 divided by 32. And then I'm going to have x equals negative 32 minus the square root of 320 over 32. Now take a look at this second one. You're going to have a negative number on top. So I'm going to tell you right now, you cannot have a time that is negative. So I know that is not a solution. So I'm going to punch that in my calculator and I'll have my time when this object hits 20 feet. I hope that helps with section 2 from Unit 6.